So relating directly back to Christian's stuff, he mentioned that he'd been working with us for analysing PDFs, and that the purpose behind that is a Canadian government project to try and make their rather large list of PDFs that they have for all the laws, rules, regulations, applications, reports, and so on involved in being a national government, to make them more accessible to people with visual impairments in this particular case. You can easily imagine, I think, that if you are seriously visually impaired, then trying to read a government report on, I don't know, climate change that has a huge table with 25 columns and 6,473 rows is a bit of a bugger. So they want to improve the situation there, and part of it is to break apart PDFs, analyze any pictures and charts and graphs and tables that are held in that, and try and improve things like the alt text of images, so that instead of a picture saying, oh yeah, that's two white guys and a black guy in suits in what looks like a fancy building, it actually works out, oh, it's actually President Obama and Boris Johnson, in the White House. Or for the table, being able to provide a voice interface so that somebody can say, read me rows 37 to 39, or summarize column 12, things like that. So that leads into what's running that all behind, and it is the Sage-T system. Now, Sage-T is the company I'm working for. It's Sage-T is actually an acronym that stands for, and if I can get it in the right order, it is States, Activities, Transitions, States, Activities, Groups, Elements, Transitions, Events, and Actions. So it's, you're probably going to quickly work out that that's state machine based. It's actually the elements of state machine as described by Grady Booch in his book about EML and so on, plus some extensions. So the Sage-T system is based on trying to use that idea as a way of representing processes, work processes, workflows, all that kind of stuff. It's a good idea. It has some limitations. There's a lot more work needed to be done to make it really tie together, but we are getting somewhere, and this is an example. This is actually the beginnings of the application for processing the PDFs for the Canadian government, and you can see it's a relatively boring web application in its UI. We use Google's Bootstrap as a basic framework for things to make things simple for developers. So that kind of restricts how pretty it looks. We have different pages represent different states. So you can load documents and PDFs and it will process them. And this happens to be my great uncle. The more interesting stuff for developers is not really what's here and boring old pull down menus and ways of uploading files. It's the fact that we can edit that code right here from the web browser. So the dashboard that I was just showing you there has an activity, which has group, which has a bunch of elements in. And for example, what's the easiest thing I can do? The graph. I can edit the graph. So the little bar graph, where we go? Oops, come here. The little bar graph, which is showing absolutely nothing there at the moment, unfortunately, because I've got no data in the system. I'll show you another one in a sec. You can have bar charts that have got show lines instead of points. We can say where we get the data from, and we can change. The easiest thing to change for a quick demo is it's just the label, something like that. We can change what's being displayed just by drag and drop. And if we go back and refresh the page, you can see it's edited the process state. There's no data in here. Damn. But we can edit all sorts of things here. We can apply rules to some of those visual elements. So this one is counting, it's making a filter to the database to get something or other, and then it's asking the database to count all the records in the database that meet that filter's requirements, and then it will basically display them in these user. It's hard to highlight something in these user elements here. Let's see, we can add new elements quite simply, and we can save the version of the thing we're working on and then download it and then upload it to a different machine, which is how we work between running the system on a personal machine and on the big servers in Ottawa. That all works really quite well. We are using 6, the Smalltalk. Oh, I forget what the acronym stands for. SIXX as the
interchange, isn't it?
Yeah, Smalltalk interchange,
yeah.
Something like that. It's basically quite like XML, but specialized and a bit more efficient. It has the great virtue that it compresses exceedingly well, which is useful for our application files. And the application files basically just hold the what I guess you'd call the schema. So the application file holds the definitions of the different states that these various pages represent. Oh, I haven't even loaded that one up yet. And sort of specs for everything appears, and then the actual data is stored in a Postgres database. And the interesting thing there is that it's a patented way of doing it, so we don't make lots of tables. We have 7 tables, one for states, one for activities, one for groups, etc., etc. And that means that it's all linear, and as the amount of data increases, the time it takes increases kind of linearly, rather than you ending up with thousands of different tables in your database and the complications that causes. There's pluses, there's minuses, there's things I believe and things I don't believe about that, but it works. The key thing really that's of interest to Smalltalkers is that A, it's entirely written in Smalltalk, and B, it's presenting a developable, a dynamically developable system. Get the right syllables in there, it helps. And we've built a bunch of tools that allow you to configure and set and save and load and so on. What we don't have yet, and I would be very interested in hearing about things people have done relating to it, is any way of debugging through this interface. For example, where's a button that's got a rule? No, that's not got one there. So let's take a look here. Elements, that's a rule. So rule items have code. We can edit them and we can save them, but currently we have absolutely no way of debugging at any level on here, other than putting a self-halt in there and seeing it in the actual Smalltalk image and fixing it there, which of course is not very helpful to somebody that's a customer of the text-to-software system. So if anybody's got experience of presenting a debugging interface through the web, I would be interested. The bigger picture part that's of some interest here is the analysis system, which is not currently doing anything very helpful. What we had in a previous VisualWorks-based system and are still in the middle of bringing forward, you could basically import a Word document or even a PDF, going back to PDFs and so on, and take the text that's in there and use it as a way of building the basics of your application, as long as you describe things the right way. And indeed, you could save an application as a text document. And if you read the text document back in, it would build you the same application. That's being, I think we're diverting that into trying to actually use some AI stuff, which we use a lot in various projects. I'm going to stop there.
Just as a little nudge, because we are hitting the 10-minute boundary there. So,
so it's a web-based development system for what they call low-code systems with AI facilities in the background and written in Squeak, running on servers. And hopefully sometime in the not too distant future, I'll be able to come here and say, hey, I want to hire 4 or 5 people.
Cool. Any questions for Tim?
Any questions at all? Is everybody completely bored?
No, I just want to confirm, looking at the status line at the bottom, it seems that you're using Seaside, but you did not explicitly speak so.
Yeah, I didn't mention it. It's Squeak running Seaside. Levente's Postgres code. Oh, actually, there's one small thing. Is it in here? Blocks. Oh, yeah, I don't have a version that's running an up-to-date one. We're also working on using a Blockly-like interface as a way of writing those code fragments I showed you. And so, yeah, anybody's got ideas on debugging Blockly type scripts would I'd very much be interested to hear from. I have some experience of trying to do that with Scratch, but that's a quite different world.
Yeah, I thought to mention Scratch, right?
Yeah, Scratch has all sorts of fun aspects, but debugging is not a strong point.
I mean, Seaside has a sort of code debugger visualization thing in it, hasn't it? Can you not leverage that somehow? Just a bit too dangerous.
Seaside's got a fairly lame code browser.
Yeah.
But one of the things we'd rather avoid is not have people digging around Smalltalk code too much.
Right.
At the moment, all the scripts are written in Smalltalk, and that's one of the reasons why we're trying the Blockly thing. Though against that, Smalltalk is quite easy to teach the basics of to people if you can provide some simple tools to explain, and if you can provide a limited environment. Some people might remember the Learning Works system that Park Place put out. I helped to deal with the early version of that, and that was a way of restricting what you see in the browsers to an arena that's within a tutorial. And that was kind of nice because it meant you didn't get people suddenly dive off and saying, what's all this compiler queue stuff? I don't know what that's about. I can't do my homework. No, they got to see some bits of integer and string and boxes and relevant stuff. So yeah, providing access that helps people as opposed to overwhelming them is an interesting pedagogical argument.
So not from a debugging point of view, but from a helping people point of view, I'm wondering if you've tried doing the kind of the gemstone approach that we've got, where if something goes wrong in the application, the user gets a friendly message saying, hey, something went wrong, whatever. But behind the scenes, we save the continuation.
Yeah.
So that we have this the luxury of being able to see, oh, you know, this thing went wrong. We're effectively got a snapshot of the stack and are able to look at it. And so, you know, they'll say, hey, something went wrong, and you can look at it. It's not a real time thing, but it's proving to be very helpful for us. Anything like that helpful for you?
That's an interesting idea. I mean, you know, I save the stack dumps to a log file, that kind of thing. But yeah, actually saving something live would be nice.
Yeah, that's the luxury of Gemstone being persistent, right? What I've got is the actual live stack, right? So you're actually walking through it as if it was a debugger. The only quirky part of that is if you try to inspect something, you're inspecting it in its current state, not in the state that it was when the stack got saved. But from a help wanting to understand what happened to a user at the time that the exception occurred, it's very helpful.
Yeah, I like that.
Yeah, another thing that you can do too, it's more for doing post-mortem debugging, but you can use something like Fuel, where actually you dump the whole context to a file, and then you can load that in a debugger, which is going to be static, but you still will be able to step through the different contexts and see exactly the states of the thing. I mean, it's not as Gemstone, but it's still, I mean, the Gemstone, you have the problem that the object pointers point to the latest version of the object, or the actual object. Here you can just dump the state, and it's still better than plain text, in my opinion.
Yeah, I mean, another really extreme way of doing it that struck me in the sense of one of those crazy ideas you have that's probably too crazy. Dave Lewis has done the Squeak OS process system, and that can spawn fork/spawn a copy of an image. I mean, on a Raspberry Pi 4, it can do it in around about 100th of a second. So one extreme idea is, okay, there's an error. Okay, fork the image and leave it off running as a debug image for somebody to look at later, and then try and recover and let the user carry on. And then you've not just got the immediate stack, but you've got the actual running image that had the problem right there. It uses a bit of storage space, but you know, storage space is cheap, and besides, somebody else is paying for it. So what? Oh,
it depends on how many errors do you have. I mean, if you have many, then they can easily eat all your storage.
My code. How about you?
Well, I have some.
This sounds like a future topic that we could explore again in some detail. Maybe someone could do something, a session on that. You know, like Esteban, I've done a fuel dump, and you know, when you restore the context, you can actually drop stack frames and execute it, but you are in a kind of a pseudo state. But